Okay, cool. All right, let's see. Okay, good. Now that's running. Okay, now we're live. And then let me make sure the chat's running here. Oh, it's all self. Yeah, dude, self-paced is the hardest man to stay motivated with. I totally agree, Famished. Very difficult to stay motivated with self-paced stuff. You know. Oh, one sec. Why is this? This is not subscriber only though. The fuck? Oh, man. Let me see. Test. Okay, that comes through. All right. I don't know why it says this is. Okay, where do we leave it? Self-paced stuff is what my friends called University de Mañana. That's great. I love that. Yeah, it's University of I'll deal with this shit tomorrow. Okay, this is 10. This is 10. Water flows into the tank, so water's coming in. I also like really I need deadlines. If I don't have a deadline, I just kind of like push shit to work on stuff that I actually want to do. And it leaks out of the tank at 4. Okay, so then it's coming out of the tank. Let's have this like leak out. It's coming out at 4h squared. Okay, where h is the depth of the water after t seconds. Okay, so then I'm running out of like water. But here, let's say that the water is like a nice aqua blue when it's in here, but it's coming in as like a dark blue. And then this is h. Start doing multivariable calculus problems from my server. Yeah. Yeah, that's the stuff he wants to do. He's goated. I appreciate that, dude. Thank you. Thank you, Ethan. Okay, so find the time. So okay, height, the height of the water, h of t, is gonna be equal to like some initial height. Let's say like h0, right? Or whatever it's at, right? Well, it says initially the tank is empty, so that's actually kind of nice. So this is 0. And actually, ooh, I think I know how I want to write this. Sorry, I want to write this as dh dt, right? Yeah, this is what I want to say. The rate of change of the height is equal to the rate coming in. So that's going to be 25. Because this is dh. That's dv. Ooh. Wait, one sec. I gotta think about this. Yeah, let's write down what we have. This is what I want. Sorry. dv dt, the change in the volume of water, is 25 coming in minus 4h squared coming out. That's it. That's what I want. Okay. And then this is going to relate to the height. We're going to get to it. Yeah. Okay. Yes, so far, great. Where h is the depth of the water after t seconds. Okay. So then, if I want to, let's say, let's move the dt over here. Yeah. Yep. I think we are going to get that. So dv is equal to 25 minus 4h squared dt. And then, if you integrate both sides, right? So this is going to be from the volume equaling 0 to the volume equaling like, let's say like v of t. What's up for Mistral? Integral dv is just v, so this is going to be v of t. And then this integral dt is going to go from t is equal to 0 to t equals t. What is dv? dv is the change in the volume. So the change in the volume is equal to, you have water flowing in at 25 cubic centimeters per second, right? So that's volume of water coming in. And then it says water's leaking out at 4h squared. So that's the dv out. Yeah. So what we say is like dv dt like net is equal to like dv dt in minus dv dt out. Or like rate in minus rate out. And that's kind of what we wrote here. So then we move the dt over, and this is an integral. And now our bounds are that volume is starting from its initial volume, which we say is 0, because initially the tank is empty, to a final volume v of t. You just have to figure it out. And then doing this integral, we're going from time equals 0 to time is equal to, we'll just say t. Some t final. How tips to dude, power naps, Dak. I'm a big fan of power naps. Like a little 30-minute nap like does wonders sometimes. I love the power naps. Yeah, often it's given, or you can use the rates of change. So here, this is going to be 25t minus 4 over 3 h cubed. Or no, sorry, not h. No, sorry. What am I saying? Minus 4h squared t. Yeah. Power naps can be improved by drinking beer.
Surprise, motherfucker.
No, dude. Anytime, the second I start drinking, it's not fun. Okay, but here's also the interesting thing. H is a function of t, though, right? Yes, thank you, Femvox. Yeah, H is also a function of t. Oh, man. Okay, so I think we have to relate them, right? So wait a minute. Yeah. So, V is equal to the base times the height, right? That's the volume. So that's equal to 10 squared h, or is equal to 100h. Got you. Okay. So this means that... Okay, so before we do this integral, we actually can't do this yet. My bad. I forgot that h is also a function of t, so we can't do this. One sec. Before we do this, you want everything to be in terms of like either variables of v or t. From this we get that h is equal to v over 100. So now I can replace this with dv dt is equal to 25 minus 4 times h squared, which is v squared over 100. Right. Yes, sorry. I need only 2 variables, like v and t. Because now this... is this separable, though? Ooh... Ooh, okay. No, this is a differential equation. Okay, I think I get this. All right, sorry. So this is v prime plus... Sorry, this is 100 squared too, right? It's v, because it's v squared over 100 squared. Why is v equal to 10 squared? Because volume is equal to length times width times height. And then because the bottom is 100 here, is 10, right? So it's 10 times 10, which is 100. dv dt is equal to 100 dh dt. Yeah, you're good. 25 minus 4h squared. dv dt equal to 100 dh dt. Wait, where are we getting that? Oh, wait. Maybe from the... wait. I actually do like this. We can leave things in terms of h. Ooh, I do like that, actually. All right, let's leave this. Okay, because from this, v is equal to 100h. Now I can take ddt of both sides. Oh, that's actually really smart, Fembox. Thank you, Fem. You're a genius, dude. Okay. Yes. So dv dt is equal to, so this is 100 dh dt. Oh, beautiful, actually. Oh, nice. Okay, so yeah, fuck this. So now I can replace dv dt with this. I mean, it's kind of the same thing. Okay. So then 100 h prime plus 4h squared minus 25 is equal to 0. Or sorry, it was just equal to 25, right? This is a differential equation, but it's not homogeneous. Right? But we can solve for the homogeneous solution, I think, first, right? So I can say, like, you know, first solve homogeneous. Yeah, well, yeah, so that's some geometry. Yeah, you gotta know the equations for shapes. So, oh, someone says Laplace. Do you think we want to use the Laplace transform here? I don't know if I want to. Someone says Laplace. I don't think it's separable. Well, it's yeah, but the H and the T is not separable, Fem. That's the only problem. Right? F equals MA. That's unfortunately not going to help us here. Oh, wait a minute. Okay. It is, sorry, Fem, you are right. It is separable. Because I can just pull this over here and then pull this over here. Yes. You're super right, actually. Sorry, I was making this harder than I needed to. This is 100 DH. Yep, thank you, Fem. Fem's carrying this question. This is equal to DT. Beautiful. Okay, now we can solve it. Now I integrate this from 0 to T final. And then I integrate this from a height of equal to 0 to a height equal to H. Okay, very cool. This is just going to give me T final. This is 100. We're going to have to do trig sub for this, right? This is, I think, arc sine. Let me remember which one this is. Yup. Okay, so anytime you see, well, actually, I don't have a square root on it, though. Maybe I still want to do this, though, right? I think I still want to. If it was plus h squared, it would be, nah, it would be tangent if it was plus. But it's minus. Yeah, I think this is hyperbolic trig. Yep, here we go. Yeah, this is it. Arc cinch. Ugh. Fucking gross, dude. What? Who's gonna remember arc cinch? I don't remember arc cinch. Can I see this image, please? Where is it? Where is that? Partial fractions, also probably possible. I think we can just do with arc cinch. You are right. This is the same thing as 100 DH. And then this would be 5 minus 2H. 5 plus 2H. And then you could do partial fractions for this. Kind of a mess. I feel like we look at trig in a very inelegant way, and there's got to be a better way, but I don't know how. I agree, dude. Trig needs more love. Oh, partial fraction gives 2 ln's, which is equivalent to arc cinch, I think. Okay. We could do that. I agree. Do you guys want me to do partial fractions, or do you want me to like... Do you want me to use the... the thing that looks really nice? Interesting that there's a sign thing in here. Okay. Well, we can pretend partial fractions, is it? There are a lot of shortcuts waiting to be found in trig, I think, yeah. Okay. Let's try and do partial fractions. Just because I don't know if I would have gotten the cosh thing anyways. So, yeah, what is this? So this is 1 over 5 minus 2h. 5 plus 2h is equal to a over 5 minus 2h plus b over 5 minus 5 plus 2h. Yeah, they do rattle my brain, dude, yeah. But this we know how to do, right? Because then what I do is I just multiply everything here by 5 over plus 2h, 5 over plus 2h. And then also by 5 minus 2h, 5 minus 2h. So you get 1 is equal to 5 plus 2h times a plus 5 minus 2h times b. Or that 1 is equal to 5a plus 5b plus 2a plus minus 2b times h. This is partial fractions. And now you got to solve this. What's the square root of 1? I think it's just 1. Could be negative 1 as well. Okay, so then we do this like by terms, right? So this is like h to the 1. This is all technically times h to the 0. This is also h to the 0, and then it's like 0 h to the 1. So if you match by like by order, like order of h, that tells me 0 here must be equal to this. 2a minus 2b, which just gets you that a equals b. Beautiful. And then the square root of 1 is not negative 1. I mean, the principal... The principal root is 1, but I think negative 1 still works though, right? Negative 1 times negative 1 is positive 1. And then from this one, you have 1 is equal to 5a plus 5b. Cool. So since a equals b, that's the same thing as 1 is equal to 5a plus b is equal to a. 5a, which is equals to 10a. So a equals 1/10, and b equals 1/10. Beautiful. Can't be if it wants to be. Yeah, it's it's 2025. You can identify as whatever you want. Okay, so that means for a here, it's 1/10. So you get 1 over 10. 5. What's that? 5 minus 2b. One sec. This is crashing for me for some reason. Why did that crash? I don't know why I just lost that. Over 1/10. So we have 100 times, and let's just pull the 1/10 out as well, right? And then this is the integral of 1 over 5 minus 2b. Or 2h, sorry. My b's are looking like h's now. All right, there we go. What's going on, Michael?
Good job.
Michael Salama. Sorry, this is a b. This is an h, sorry. My b's are actually starting to look like h's. Oh, it's confusing me. And then plus the integral of 5 plus 2 over h. 5 plus 2h. And then this is all dh. Nice. Okay. This is just a logarithm. So this comes out to be 10. And then this is going to be the ln of 5 minus 2h. But then it's u sub. So I think there's a 1/2 in front of it as well. There's a negative 1/2, I believe. And then this is plus positive 1/2 ln of 5 plus 2h. But then all this was evaluated, right? From 0 to h. Yeah. So actually, we got to come up with some stuff here. Okay, so another 1/2 is going to come out. So that's going to be negative 5. Then we have ln of... The cool thing, when you have bounds for, like, ln, and you're doing it, you can always just do ln of this plugged in divided by this plugged in. Because ln of a over b is the same thing as ln of a minus ln of b. And so whenever you have integrals with ln and you're doing bounds, this is the ln of this getting plugged in minus the ln of this getting plugged in, which is the same thing as the ln of that divided by that. Wait, h is a variable and a constant. Yeah, isn't it cool? It's a cool shortcut. Yeah. Right. So this is, I know it's the same thing. My bad. It's 5 minus 2h over 5, right? And then plus ln of 5 plus 2h over 5. Which, this is cool, because now I have ln's of two things adding to each other, which is the same thing as their arguments multiplying. So now we have negative 5. Did I do something wrong here, Zach? Careful with the negatives. Oh, wait a minute. No. What do you mean careful with the negatives? I think we're okay. One is negative. You're right. Sorry, this one is negative. Thank you. Sorry, because I pulled the negative 1/2 out of here, and I forgot about the negative 1/2 here. You are so right. Yeah, so what is this? So this is... Okay, so now they're dividing by each other. So this is ln of 5 minus 2h over 5 divided by 5 plus 2h all over 5. So the 5's cancel. And so I'm left with negative 5 ln of 5 minus 2h over 5 plus 2h. Which, if I want to get rid of the negative, you can kind of like pull it up top and then just switch the arguments. So this is 5 ln of 5 plus 2h over 5 minus 2h. Nice. And that's h. Wait, but this is supposed to be a function of t? Oh no, we get t is equal to this. Yeah, sorry, this was all equal to t, right? Yeah, it's all equal to tf. Sorry. Okay. So this was... TF was equal to this. Cool. So I think they probably want the height as a function of t, though, right? Oh, okay. All right, so... divide by 5 first. So t over 5 is equal to this. What's up, Alistair? And then you just do e to the on both sides, right? E to the. What's the units? We're going to get there. That's in centimeters. Is equal to 5 plus 2h over 5 minus 2h. Kind of annoying. Is there a shortcut to do this? I don't think there is. 5e to the t fifths minus 2h e to the t over 5 is equal to 5 plus 2h. Group the... Okay, 5e to the t over 5 minus 5 is equal to h. And then that's 2e to the t over 5 plus 2. Right, if I move that over and then I pull the h out. Yeah. Okay. So h is now equal to 5e to the t over 5 minus 5 all over 2e to the t over 5 minus 2. Okay, key thing here, because we can do some checks, right? I need h of 0 to equal to 0. And I think that does work, right? Because e to the 0 is 1, 5 minus 5 is 0. Well, it's 0 over 0, so it's actually undefined. Where is the plus... Oh, sorry, this is plus 2. Yes, thank you. That's actually what makes sure this doesn't, like, fuck up.
No.
Yes. Was it asking for time? No, I think it was asking... Sorry, what was it? Oh, find the time taken for it to reach a depth of 2. Oh, very cool. Oh, actually... Oh, so we could have just stopped here. Yeah, okay. So actually, this was... Very good question there, Matombo. Yeah, I forgot that, like, this is the actual question. So... when h equals 2, t equals 5, ln of 9 over 1. How do I become a mathematician? Do math. Have curiosity. I think that's all you really need in life. It is the one thing, I met with Balint at TwitchCon. He runs Science Stream. And I did because someone asked him this question. They said, what does it take to become a scientist? And he put it quite well. He said, all it takes to become a scientist is curiosity. If you have curiosity and you want to solve shit, like, you are technically a scientist. Okay. 5 ln of 9. So around 11 seconds. Yep. So I'm going to say t is around 11 seconds. Let's see. That seem about right? Seems like a lot of time. But I think we're okay. Yeah, let's see. It's 10 by 10. It's flowing in at 25 centimeters cubed per second. Yeah. Looks good to me. Nice. All right, we'll call it good. Good job, guys. Love it. This was Ain's question. Ain. Nice question, dude. Cool. My whole degree is stats. Stats is cool. Fan of stats. Okay, nice job, guys. Sick. All right, let's go to the next question. Again, if you're just joining us, Femvox has spoken, exactly. Dude, I'm going to give him that thing. He is... Oh, Clickbait said, yeah, I gave up on that one as soon as I saw the integral and got back to my homework the other day. Yeah, I felt like it was going to be an easy question. When I originally saw this, I was like, oh, great, this is just a related rates question. But then I saw there was a rate in and a rate out. And I was like, oh, fuck, it's a differential equation. And I originally was going to solve it with Diffie Q, but then Femvox made the great pointing out of that, oh, it's a separable differential equation, so you don't have to do all the weird shit. Laughing Disco, thank you, Ambob. Can I do simul K tasks? I don't know what that is. But you can submit it. I can probably try to do it. So, yeah. If you're just visiting us right now, the website is www.actualofficehours.com. And there you can drop in a screenshot of a question you want to go over and just hit upload and we'll go do it. Yeah, you still have to do some weird shit? Yeah. Dude, why is Twitch, like, monitoring my chat? Dude, what? It's making me, like, allow people to say shit. Of course you can say shit on my channel. I don't care. But, yeah, shout out to Zach, by the way. He's another awesome math educator. So, while you're here, if you go click on the streaming schedule, you can see, thank you, Bob. You're sending all these jewels. I love all these things, by the way. Of, like, when people are streaming. So, Zach had a really cool... I hope you went and saw it. He had a very cool podcast stream with Penn Center this morning. And... Well, it looks like no one else is doing streaming this week. Well, it is a holiday week, honestly. It is holiday break. So we're going to do a stream tomorrow. And then I think Penn Center is still doing Riemann services on Wednesday. Never treat dy dx as a fraction except in separable differential equations. Then it's fine. Yeah, right? Dude, people getting mad at me for, like, my... Can we show how the mic is connected? Well, it's connected with... I mean, what? This mic? It's just connected with a USB cord. How many questions are you going to do? Well, I have 2 hours and 15 minutes, so I'm going to do as many as I can do in 2 hours and 15 minutes. If not, we have other awesome people that are here to help. Let's look at what Millie's got. Prove the sequence is convergent. Ooh, okay. You have a taco tie? I love tacos. Tacos are great. You have a mic that loses connection? Check your USB cord. Honestly, I've had that issue before. Like, it keeps disconnecting. To me, it was my USB cable. I just switched it out. I hated calc too. Zach, I don't know if I've seen your taco tie. Maybe. So basically show that the series converges. Why didn't they say so? Yeah. I feel like you can do this by the p-test. Right? Yeah, sine of n is less than 1. Yeah, just compare it to 1 over 2 to the n. Yeah, exactly, yeah. This is a limit comparison test. So, for instance, we know 1 over 2 to the n converges by... Is that called a p-series, I think it is? Can't we just say GG, easy clap? Yeah. And... Do you want me to do the squeeze theorem? I can do the squeeze theorem, too. Oh, it's by geometric. It's a geometric series, right? Right, geometric series. Oh, I don't know. TikTok has its own little moderation thing, Fanatic. I don't know what it does on its chat. Okay, and since... What's up, Baka? Then you show sine of n over 2 to the n converges, which shows that the sine absolutely converges, which shows that it converges. Yes, I mean, I think I can. What I can say, right, is that, sine of like whatever is always less than or equal to 1, right? Or the absolute value of it, right, is always less than or equal to 1. So sine of x over 2. Yeah, you do have to say absolute value. You sound stuffy, breathing. Yeah, my nose is a little rough. Yeah, technically it's not. Yeah, because it doesn't alternate every other series. Yeah, because it's like sine of 1 and sine of 2 are both positive. Sine of 3 still positive. Sine of 4 is negative. And then sine of 5 is negative. Sine of 6 is negative. And then sine of 7 is positive. But for comparisons, all terms must be positive. Oh, for the limit comparison test. Okay. So this is always less than or equal to 1 over 2 to the n. And this converges. So this must also converge. Oh, you do? Okay, cool. I'm glad, Fembox. Okay, so then we've proven that shows convergent and then compute the value of the limit at infinity. I don't think we have to prove what it converges to, do we? Okay, if sine of x over 2 to the n converges, how do I prove that this also, removing the absolute value, converges? Is that because it's alternating? Ish? I know it's not perfectly alternating. Or sorry, this is sine of n, not sine of x. Oh, absolutely convergent series are convergent. Oh, okay. Okay, I see. You can say converges absolutely. Sorry, it's the other way around, right? Things are conditionally convergent if, for instance, they pass alternating series tests, but once you remove the alternating, that they don't converge. If something converges with all the alternating stuff removed, the alternating stuff definitely converges. Sorry, I keep writing x, sine of n. So, sine of n over 2 to the n also converges. Yes. Right, it's easier to prove things converge absolutely. And then that implies that implies the one where we don't remove the absolute value. Extra challenge. Does someone want to compute what this converges to? I don't know what it converges to. I'm gonna guess that I mean this component converges kind of to 0, right? Does it converge to infinity? That's not converging.
Disqualified.
You can't converge to infinity. That's diverging. Yeah. I think maybe you could do this in terms of a series, right? Because I think we know what n equals 1 to infinity of sine of n is, right? Isn't this equal to like some sort of series? I can converge to infinity when my mom told me so. I can do anything. Yeah. Oh, the answer is not easy. Oh, okay. Let's see. Oh, this is fun. Oh, interesting. Wow. Oh, so sine of n is equal to the imaginary part of e to the in over, and then it's over 2. Oh, okay. So this is kind of an interesting part. Okay. This is the easiest way to do it, right? This is what we just did. This is apparently... I'll include this in here if someone wants to like actually find out what it converges to. But that wasn't really necessary in the question. But pretty close. Yeah, this is like some property of sine. Sine is all the imaginary stuff. E to the I. Nice. Okay, great. Cool. Great question there. Thank you, Millie. What's up, Krish?
Well done.
Welcome in.
Well done.
There's cheese in the back. Fresh root beer on tap. Grab a chair. We're going to be doing some math today. And some physics and science, if someone wants to give it to me. I think Clickbait's going to give me my dose of physics today. What the fuck is burning my eyes right now? Is it math?
Oh shit, not good.
Oh no, is it math? Alright, good question from... Zach, are you going through and helping out doing some of the vector field questions from yesterday? I appreciate that. Yeah, Zach's being a G right now. Thank you, Zach. Yeah, these ones didn't get solved. Cool. But yes, if you're watching, welcome. Every time we do one of these questions, I do also post the solution in our Discord. So make sure to go join our Discord if you want to like see what's going on. So here, it's in the homework help channel. And so this question was done by Millie. And so what I'm going to do is I'm going to drop the solution in, and there it is. So now Millie has a solution. Also, if we don't get to your question today because maybe the queue gets a little long and I run out of time, not to fear. Zach is here. And all the other awesome actual educators I have like in my Discord. So for instance, this question was asked yesterday during our stream, and I didn't have time to get to it. It was about vector fields. along a curve. Very cool. Zach went ahead because he's awesome, and he wrote the solution for it. Thank you, Zach. That's awesome. So I say, you know, like even if I can't solve it during the stream, either because I don't know, I can't figure it out, or I run out of time, still just submit it, because I guarantee you someone I know can solve it, and they would be more than happy to help you out. Series really suck? No, series are great. I love series. Oh, he forgot to multiply Nero. Oh, Noroski. Oh, did he? He forgot the factor of 2, you think? Can you do a step question? What's a step question? My question is 27 marks. Good luck. And does that mean it's difficult? If you give me something too difficult, I'm just going to pass on it. But let's see what you got, Ethan. What do you got for me? Oh, Jesus. A particle on a string. Ooh, this is a nice differential equation. DEs, yep. Oh, wait, that's not what we're doing. I thought I got this. Not this one. Is it Laplace time? Is it Laplace time? Perhaps. I'm tempted to say it's Laplace time because I see an e to the minus t, and then these look like Heaviside shifts or something. Has Dr. Gold been paying attention?
You don't mess up anyone!
No.
Shit. Oh man, have I been paying attention? They say. Oh, that's a good point. Okay, I have to remember all my stuff. Let me go. Can I get like Laplace tables here maybe? Where are my Laplace tables? This is your final exam. Good skill. Okay. So we have second derivative. I could find the particular solution. I could find the homogeneous solution for this, right? Pretty easily. If I just, you know, use the e to the whatever thing. That kind of works. I think that's where that would come from. I would just use undetermined coefficients, I think, because I know how to do it and I don't have to look up tables. Yeah. I think we can do this, yeah, through a Laplace transform. So we got to take the Laplace of both sides, right? That's what we do. Ready, set, go. Let's see who gets it. Okay. So we have x double dot plus 2x dot plus 5x is equal to 4e to the minus t. And I think this is 2 of these, right? Do I want to separate them? No, or could this be like a convolution? Is this like convolution theorem? Okay, whatever. I know that's how that works. Let's do this one first. Let's Laplace transform this. Can you get x prime and x double prime and plug it into the left side? Not exactly. Cantor says I should distribute it. Okay, I will distribute it. Let's do it. I was kind of thinking I needed to. Psst, auxiliary equation. The auxiliary equation? What's the auxiliary equation? I had no idea to do this question when I got it. Yeah. I mean, so the easy way to do this is to first like set this equal to 0. And this just becomes like x double dot plus 2x dot plus 5 x to the 0. Or the 0th derivative of x equal to 0. And so this gets you like a squared plus 2a plus 5 is equal to 0. And then, well, I guess these aren't like really nice things, are there? I was hoping this would factor nicely, but it doesn't. But that'll get you... oh, these are imaginary solutions, right? Yeah, because look at this. This is a is equal to -2 plus or minus the square root of 4 minus 20 all over 2. Yeah, so it's -2 plus or minus the square root of -16, which is 4i all over 2. Oh, cool. So it's -1 plus or minus 2i. Yeah, and when you get this for the solutions, when we assume this was e to the... right, x was equal to e to the at, this gets you the sine and cosine stuff, right? Yeah, it needs to be imaginary if you have sine and... yeah. Well, of course, yeah, I mean, and that's what we get from this. So when we assume x is equal to e to the at, and then you do this, you get this. You get a is equal to that. I forget how that works, but this is like a sine and cosine thing eventually.
Nice.
Let's try to do it with Laplace transforms, though. I think I can do it with Laplace. All right, so I'm gonna take the Laplace transform of the left right here. Markovian math. I can try. If I can't do it, I have other friends that can do it for sure. Look at my Laplace transform table. What's up, Faizan? How does it work with derivatives again? Does it just pull down an x or something? Yeah, check out the Discord. +1. Thank you. Sorry, were there things in derivatives here? Oh, that's it. Okay, cool. Yeah, I'm gonna use this one. Ooh, here we go. Laplace was an S tier guy. I mean, what a guy. Yeah, because he loves using S's and all his stuff. Why did he choose to use all the S's, by the way? Do we know? Okay, so this is kind of the fun. Okay, so if this is the second derivative of this, right? Because that's x double dot. That's gonna be s squared f, right? Minus s to the first f of 0. But I think we already know what f of 0 is. We know x of 0 is equal to 1, right? Yeah, so in this case, f is equal to x. Okay, so then this is times x of 0. Yes, yeah, we did do that. I did do this solution for the homogeneous, and it was already this. It's already complex, so I figure we do this, we might pull it out easier. And then this is minus s to the 0. Well, s to the 0 is 1, right? And you go to the n minus 1 term. Right? Wait, what? Why is it says dot dot dot? Okay, I'm pretty sure this is s to the 0, which is 1, and then that's x dot of 0, right? And I don't think I do s to the -1 at this point. Well, also because I think, like, yeah, an x dot of 0 is there. Yeah. When a shading region is rotated, it forms volume, but why do we integrate area of a circle for every value of x? Because if you have the nth derivative, it keeps going. Okay, but I go down to the 0th derivative, right? Thanks for the follow, by the way, Wafer. Okay. And then we know this is equal to 1. And then x dot of 0 is equal to 2. Okay, cool. So that's equal to sf squared plus s minus 2. That's the first part. Okay. So then we have 2x dot. So, sorry, this is just the Laplace transform of x double dot. This might be getting messy. Okay, so then the Laplace transform of 2x. Well, that's equal to 2. S to the first f, right? And then the 0th derivative. Times the function at 0, right? Right. So then that's minus s to the 0, x of 0 again. Cool. Factors will factor out the 2, then multiply afterwards. Yeah. Okay, whatever. We'll do this, right? Is that cool? I think it's cool, yeah. X of 0 is 1. So that's 2sf minus 2x. Oh, not 2x. Sorry, just 2. Sorry, because x of 0 is 1. Yeah, okay, cool. Great. And then the Laplace transform of 5x. That's just 5. Right? If it's just a variable, it's just, I think it's just 5. Yeah, W Laplace, right? Yeah. Well, that's if it's a constant. It's just 5f, is it? Oh, AT. Wait, one sec. Boom, 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 boom. Z transforms up next. Uh-oh. I could have. You're right. Okay. We're getting there. Okay, and then the Laplace transform of... What is that? 5x? Sorry, this was 2x dot. I think you dropped the square of the s in the second derivative. I did. You know, I put it on the f squared. That's what I did. Thank you.
Huh?
Yeah, I did fuck that up. Sorry. Okay, Laplace of 5x is just equal to 5s. Right? I think we're good? Or not 5s, sorry. 5 big F. That's what I meant to say. Yes. Okay. So what do we have now? Okay, so we have s squared f. And then this is 2sf plus 5s. So I'm going to say plus 2s plus 5. Or wait. I think I want to... How do I want to group them? I think I want to group them by f. Yeah, let's group them by f first. Okay, sorry. So that's s squared plus 2s plus 5, right? Is it 5 over s? Well, so if it's a constant, then yes. If it was a constant, it would be 5 over s. But it's the function f, right? Or sorry, it's the function x. Yeah, Cantor says it's just a polynomial times 5 times f. Bum, 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 bum. I don't see it on the table here, but I'm pretty sure. Let me find that for you, actually. Sorry. Where do I see that? Of a constant, it's 1 over s. I think of the function though, it's 5. It's just because that's the derivative. Where's just the? I think it is just. I think it's just times f. Oh, okay. This is actually the other way to see it here. You want to see it for this one? Yeah. Okay, so by this rule, right? If you're taking the Laplace transform of this, right? And then here, just assume a equals 0. Do you see how this just gets you f? F of s minus 0, so it's just f of s. If I were to take the Laplace of both sides. I think they don't include it on a lot of tables because they just assume it's like, it's trivial. Do you see that? That's why I think it's just 5f. X is a function. T is the thing it's dependent on. I understand why that's like kind of tricky here. Because in this case, like, f of x is equal to like x of t. We have to be kind of tricky here, right? This is x of t. Usually, yes. Usually, it's like, I guess f of t maybe, or it's f of x. Okay, I think we agree with this so far. It's this f minus, and then what's left on the other s stuff. So I have s minus 2 minus 2, so that's s minus 4. So plus, and then that's going to be s minus 4. Okay, cool. We got the left-hand side. All right, let's do the Laplace transform of the right side, which is Laplace transform of these. Cool. So here, this is left-hand side. You're 1 term away. Wow, Zach is doing this so much easier. So much faster. This is left-hand side. Here, let's do the right-hand side. I can tell I need more practice with Laplace transforms. Thank you whoever asked this question, because you're giving me the fucking ringer of like how to do this. Okay, let's do it. Let's do the Laplace transform of this. Okay, this is where... Oh, I wish I didn't erase that one thing I had. Okay, but this is it, right? Where was the e to the at times f? What level math is this? This is Calc 3 for sure. Or, sorry, differential equations. Fuck, wait, where did that thing go? I just had it. But then here's also... yes. Yeah, this is actually the one, right? If you take the Laplace transform over this, you get this. This is why Laplace transform of x of t is just capital F. Okay, so there's something here with omegas. Do I want the omegas? But I think we can do these, yeah, right? X is not the variable I care about, yeah. I think I'm gonna use these. Wait, and I have a negative on them, right? Someone said this was an A-levels question for further math, though. Which here's also my question. Do you get these tables on your A-levels? Because if you don't get these tables, I mean, you're kind of fucked, honestly. You do get the tables, great, okay. So in this case, A is equal to 1. And then omega is equal to 2, right? So this is going to be 2 over s plus 1 squared plus 2 squared. And then plus... And then there's also a 4. Sorry, there's a 4 outside everything as well. Without the tables, yeah. Yeah, that makes sense. Okay, this is s plus 1 over the same thing. S plus 1 squared plus 2 squared. Okay, cool. At least they have the same denominator, right? So that's equal to 4s. Right, 4s plus 12. TikTok live, yeah, dude. Laplace transforms, they're here to stay, dude. And then this is s plus 1 squared plus 4. Cool. Nice. Okay, that one actually wasn't too bad. I think because I was given these tables, which were nice. I guess also what we could have done is if it's a shift, right? Where's the e to the at? Yeah, this one. Could have done this one with the shift. I could have shifted it if I wanted to. But we were given this, so I'm going to use it. Okay, great. Okay, so now I get that this is equal to this. How do you turn down the difficulty? Dumb question, but what is the use of the equation? So, in general, I mean, correct me if I'm wrong, other guys who are experts on the Laplace transform. The reason is I'm trying to solve... Laplace transforms are really good for differential equations because they convert things with like messy derivatives into almost like algebraic expressions. And then from that algebraic expression, you can simplify and cancel stuff into something that looks nicer. And then you Laplace back to get what the form was in your original question. I think. Because from this, right? Now I have an expression for what f is. Yeah, I think this is how it works. Because now f is going to equal, if we move this over and then divide by this, I'm going to get s minus 4 all over this s squared plus 2s plus 5. And then plus 4s plus 12 over... So that's going to be... And then, wait a minute. I think this turns into... Wait, what the fuck? Whoa, 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 whoa. Whoa, this is cool, actually. Look at this. Okay, wait. S plus 1 squared plus 4. That's the same thing as s squared plus 2s plus 1 plus 4. That's also s squared plus 2s plus 5. Oh, shit. That's really cool. So this is... If I divide by this over here, I'm just going to get s squared plus 2s plus 5 squared. Because this is also equal to 4s plus 12 over s squared plus 2s plus 5. Oh, wow. I think this is why... like Laplace transforms are nice. Right? Boom, 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 boom. Yeah, or you can use the shifts s equals s minus 1, then use one of the equations. Yeah. Wait, and sorry, was this minus 4? Yeah. And then wait, actually, wait. I think there's an error on this one, sorry. This should have been minus s. My bad. Sorry, this should have been minus s minus 4. Okay. One sec. So we could say that's the same thing as Negative s plus 4. Ooh, okay. Okay. So sorry, this should have been plus 4. Sorry, because when I move that over, that's a minus. And then plus. Yeah, okay. I saw a slight little error here already. Okay. This is the same thing as minus s plus 4. And then when you move that up, you get the plus. Okay, great. Okay, cool. All right, then how to solve this? We are going into the partial fractions world. Well, they do have the common denominator, Cantos, right? This is the common denominator. Yeah, the second one's kind of a yikes, right? Because it's squared. Okay, let's try to make... Let's put it back in this form. So I have s plus 4 over s plus 4 squared plus 1, right? I feel like I almost want to, like, just call this... Sorry, this is... Or is it? Sorry. S plus 1 squared plus 4, sorry. Could I call this like s plus 1 plus 3 over like s plus 1 squared plus 4? And then we got to inverse Laplace. What can I kind of make this look like? Let me look at my table real quick. What do we got? What do we got? I feel like I'm going to go back to doing this. Do you see how this is like s plus a squared? I think I kind of want to do that though. I think what I'm going to end up doing is Laplace transforming this back into e to the at. Cuz that kind of looks like this. Right? Let's bring these back. I think I need these. Where do we put those? Yeah, let's take these. Because this looks pretty similar. So what if we yeah, how to invert them? Well, inverting them is just going back, right? So we Laplaced from this into here, and then we're literally gonna do the other one backwards. I'm gonna say here, let's like let u equal s plus 1. And then I have, this is equal to u plus 3 over u squared plus 4. Right? Oh. Yeah, it's close. Fuck. I just want to let you know, Isabella, I took my exam today, and your help literally saved me. Thank you so much. Oh, thank you, Isabella. Bless up always also to... Yeah, it's not just me that helps out with everything. Thank you, Femvox, Zach. I know a lot of you guys went and helped Isabella with her questions, because some of her stuff was a lot harder than what I can do. Oh, you posted your... Okay. Here, I'll post this question for you real quick, Ethan. Sorry, Zach. So that it's in, you can post it in the forum thread. Yeah. Yes, thank you to you all. I really appreciate it. You're more than welcome as well.
Good job.
Made it to 1K likes. Thank you, Amir, dude.
Bing, bing, bang.
That's awesome, dude. Thank you, Amir. Fuck. All right. I'm getting such a... The first term, you can subtract the difference of the numerator to match the denominator and make two terms. You are correct, actually, right? Yeah, let's do that. Sorry, I want... Yeah, okay, let me, like, not do this. This looks like this. Right? Yeah, let's move this. Yeah. Let's do this. That's equal to s plus 1 over s plus 1 squared plus 2 squared, right? And then this is plus 3 and then this is 1 over s plus 1 squared plus 2 squared. Right? Oh, I think I know what we're going to do here. Yeah, watch this. Watch this. That's really cool. I'm going to put... Okay. Beautiful, right? Yeah, exactly. Because look, this thing is exactly the same as this. Here we have that A is equal to 1, omega is equal to 2. So when I inverse Laplace back, that's equal to this. So this is e to the negative t cosine of 2t. 3/4 times 4. Exactly. So on... Yeah? Okay, and then watch this. This one, in order to get this to look like this one, I need a 2 here, right? I can multiply this by 2 and then divide this by 2. So now, yeah, so this was me doing Laplace inversed. This is inverse Laplacing. That's going to give me plus 3/2. And then that's the sine one. So that's e to the negative t sine of 2t. Yeah, this is a demon question for homework for sure. Right? Nice. Okay, cool. So that's the first term. Okay, so we successfully inverse Laplace this.
Good job.
Great job, guys. How are we still doing this? Because Laplace hates us. Okay, so this one's done. I like it. Okay, we've successfully inverse Laplace this, right? Because the cool thing is, like, when you do the Laplace inverse of this, that's just going to get you x of t, right? But now we had to, like, Laplace inverse both sides here. No, this is a fun question. I enjoy this one. I love this course so much, I took it twice. Yo, it's like rewatching a TV show, though, dude. Like, sometimes you catch a lot more things the second time around. Okay, so we've done the first one. Let's get the second one. Let's get this one. I'm gonna do it like here. Let's do it a different color. Let's do this one in red. Because there's gonna be the water's warm. The water is warm with blood, dude. The water is warm with blood. Okay, this is 4s over, again, this is s plus 1 squared plus 4. Unfortunately, the second one is the hard one. Fuck. What's up, Fat? What's up, Mouse? Let me think. Let's go look at our tables. What do we got? We gotta make something look like this. We're gonna get close. Ooh, what about these? This looks nice. Right? This looks kind of nice. It's got the squared on the bottom I want, right? Except it's like 2 omega s. Narosky says take the second fraction as the sum. Then you can shift. Yeah, right? Because then I can shift by e to the minus whatever at or something, yeah? Or literally this one. Where's the t on it? Sorry. I think I want to use this one. Yeah, let's use these. Because that's all this. Right? Squared. And then plus 12 over s plus 1 squared plus 4 squared. I wonder if I still want to keep an s over here, right? In order for this to work, though. Actually, no. No. I think we're fucking money. We're money here, right? Or this one, right? Yeah, I just need to, like, divide by 3 or something, right? I think this one works, right? Let's do this one. So for this one, I need a 4 up here. So I have to say times 3 divided by 3, right? In order to get the... No, oh wait, this is 2 squared though. Sorry, it's divided by 6. Okay. Omega equals 2. A equals 1. Yeah? I think we're good. So this is 6 times e to the negative t sine 2t. I use, group roles, what do I use? Yeah. I think we're okay. And then what about this one? This I need an S on top of it. Oh, which I can use this one. Ooh, how am I gonna get the plus A though? Oh, man. Add and subtract a full term with the same denominator. Yeah, Narosky said, this is why I was suggesting 4s plus 4 and 8 instead of 4s plus 4s and 12. 4s plus 4. Oh, I see. Okay. I like that, Narosky. Let's do that. That's actually a good idea. So Narosky's saying break this up into 4s plus 4 plus 8. Beautiful. I do like that, Narosky. That's actually a really good idea. Props to you, dog. And then this is s plus 1 squared plus 2 squared, right? Okay, now we can break this into 4 s plus 1 over s plus 1 squared plus 2 squared plus plus 8 over s plus 1 squared plus 2 squared. Okay. What's up, dude? Oh, wait. These are the wrong ones. Sorry, I need these. Sorry, I copied in the wrong ones. Sorry, these are the ones I want. I want these. I had the wrong tables, actually. We need the ones with the squared on the denominators. Oh, we fucked up. Sorry. Yeah, these are the ones I want. Sorry, I want these. Right? Oh, now I need s squared minus omega squared. Fuck. We're using the wrong tables. Wait, because this is squared. That's the issue. Sorry. This is squared. This is squared. This is squared. Yes. There we go. Okay, does that... Yeah, So I think it'll work for this one. I'll be able to get this, I think. Yes. Okay. Yeah, I think with a shifting concept, yeah. Zach knows how to do these better than I do. Okay. I think this one is like doable. Because here, right, S is just S plus 1. So, and omega is equal to 2. Oh, so this actually works out pretty well. Right? Do you see how I have 2 times omega? Because omega is 2. So this is great. This is 2 omega. This is S. This is S. Okay, so this is actually great. This one is easy. This is just T sine 2t. Find a common denominator that gets s squared in the numerator. I got one of them. Yeah, that just works, right? Let's make sure we're doing this right. 4s plus 12, like, over this, yeah? We broke that into 4s plus 4 plus 8. So this became 4s plus 1 over s plus 1 squared, 2 squared, right? Then this is 8. This one, omega is just equal to 2, which is great, because then I get my 4, which is I need for my 2 omega. My s is s plus 1, so this is good. I don't want to look at this question anymore, but S isn't S plus 1. Why not? Can't I? Oh, I need an S plus A term. Oh, this is the shift. Ooh, yes. Yes, this is the shift. This is the shift we're talking about. Okay, now I remember. Okay. This is just a differential equation. I don't know if this is ordinary. Yes, thank you, Riley. This is the shift we're talking about. Where is the shift? Where is the shift? For the exam, you get 40 minutes for the entire thing? Dude, fuck that. No. I don't know how to do this dude, I've been spending 40 minutes just on this one question. That sucks. Good question. Well, they said this is a 27 mark question too. I want to know where this shift comes from. How do we shift it? I feel like there's an e to the t on it somewhere. Okay. f of t minus a ut minus a is e to the minus a s f of s. Okay. Fs isn't in the power of E. That's a standalone term. Yeah, no, I understand that. Yeah, E to the AS times FS. Et voila, he says. Okay. I'll say a prayer your professor doesn't do you this dirty. Yeah. Professor, I'm 17. Yeah, this is an A-level maths question. It's apparently what got handed to them. Where is that other? Sorry, what's the Laplace transform of 1 over s squared plus a squared squared? Where is that? I'm looking for that one. Oh, okay. Wait a minute. I think that comes from this. Wait. Because I don't see that one. I see this, like, s plus a to the n, but I need, like, s squared and a squared. Okay, but I do see something here. One sec. Let's look at, for instance, right, this table compared to this one. Just look at these two. So I think if you shift something by plus a for your s, you just have to stick an e to the minus whatever that is, t, on the outside of it. This is I think is the shift thing. That again isn't written. It's not written explicitly here in the. I don't see it in the table. Yeah, shift by 1, so s equals s minus 1, right? Yeah, okay. That's what I think we want to do. So wait, where were we? Yeah, here, right? So this looks like this one. Right? We're just shifting by +1. So I think this just slaps an e to the minus t in front of it. I think this is the shift. Right? That's all you need. Cool. Okay, we got that one. I'll take that one. Okay, this one is a little trickier. But I need it squared though. Fuck. And how do I get rid of the... That's S minus omega squared. How do I need another S in it? Oh, man. Okay, I'm gonna I need a little bit of ChatGPT help. Because I can't figure out how to do this last Laplace transform. Let's see. Okay, shift, then it's S squared plus 4 squared though. I need another one with a squared on it, which I don't think is in my table here. Yeah. ChatGPT cannot do math at all. Yeah, but maybe you can help with that Laplace transform. Because I need the squared. The formula I had at the beginning? Yeah, but I need it but I need it squared, Riley. That's the issue. Because there's a squared here. Okay. So we're all tripping, dude. That's what happens. Okay. I think this one is a correct transform. I'm just going to take it. This is apparently... Again, it's not given in the table. But I think it's looking okay. And then I'm going to have to shift it as well, right? Because this is going to be... Looks legit to me, right? Yeah, okay. Plus, this is 4... times 2 over S plus 1 squared plus 2 squared squared. You should go to sleep. Yeah, dude, this is painful, dude. Okay, so this is... Yeah, it wasn't easy, yeah. Okay. This is t e to the minus t cosine 2t. But then I think I have another e to the minus t. Because I had to shift by +1, right? Yeah. So there should be another e to the minus t here. Is FemFox on TikTok? No, FemFox is mainly in Twitch. Okay, so let's see what we got. So I got e to the minus t sine 2t plus 2t e to the minus 2t cosine 2t, and then plus this part? I think we're close. Because wait, what's the final answer we're looking for? This is eventually what we're looking for. Let's see if we can get to it. I think we're close. Okay, so I have Oh, this is e to the minus... Dude, oh, I need one of those e to the minus t's to go away, and then I think we're good. Because look at this. This is almost good. Let's just say it's e to the minus t. And then I have cosine 2t. I want this to be a minus t. I'm just gonna pretend it is. Just pretend it is just for now, please. Just for the sake of this question. This is cosine 2t. Oh, but then that's 1 plus 2t. Shit, I need to be 1 minus t. Oh, okay. Still no good. Yes, I can definitely help you with projectile motion. Okay. Yeah, that 3/2 seems weird too, right? It'd be like that. Assuming e to the negative 2t is equal to e to the negative t, my answer is. Yeah. Don't worry. Okay. Yeah. All right. I'm gonna. We made a valiant effort on this question. This question's a huge fucking nightmare. I'm so sorry that you got asked this question on your further maths, but I will leave it as being kind of done for now. Yeah. Let me help some other people out. Sorry.
Good job.
I agree the 3/2 is right, but like Narosky, I was getting a little worried at like how the fuck am I gonna pull a 3/2 out of here? What's that timer countdown? The amount of time left in the stream. Okay, this was Ethan's. This question makes me want to drop out. Yeah. Yeah, this question is nasty, dude. Wow. Nasty question, dude. All right, let's mark this when it's done. Thank you, Mike Salama. Yeah, so I will put this in the Discord, by the way. What's Drake doing here, dude? Okay. Here, this is the Discord question. So Zach apparently has gotten like, oh dear, but see, look, even Zach's starting to cross shit out. I'm gonna put that there for you, Ethan. Okay, cool. This is not any class in high school. Well, this is for a 17-year-old apparently, but it's in the UK. It's a UK question for further maths. What a bitch. Okay, let's do H's question. Wow, I like this much better.
Oh, yeah.
New drop. Drake with the new drop. Okay. I think this is nicer. Show that the log base 5 of n plus 2 over n plus 1 is equal to 2. Sorry, this makes my stomach hurt. Is there some rule I should know about this? I mean, I know this is a log rule. I know this is the same as the log base 5 of n plus 2 minus the log base... Oh, wait a minute. Of n plus 1. Is telescoping, right? Is this telescope? I believe this telescopes. Yes, we love telescoping. Yeah, so log of A divided by B is equal to the log of A minus the log of B. So you can, this is what we're simplifying this equal to. Let me just write out a couple of the terms, just so you can see it. So for instance, this would be the log base 5 of 3 minus the log base 5 of 2. And this is for n equals 1. And then we say plus the log base 5 of 4 minus the log base 5 of 3. This would be for n equals 2. Yes! Thanks, Ethan. I appreciate it. It was fun. So the cool thing here, and then here, let me just write up the next one, just so we can see, like, it's always good to see, like, where the, if there's any, like, weird, like, cross cancellation happening. Log base 5 of 5 minus the log base 5 of 4. Okay, cool. So, and then plus, eventually dot, 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 you're going to get to n equals 48. Which will be the log base 5 of 49 minus the log base 5. No, it's log base 5 of 50, sorry. Minus the log base 5 of 49, right? Yeah. Anytime I see log of A over B, I'm like instant cancellation, right? So, let's see. This one's going to cancel with this one. This one's going to cancel with this one. Okay. So, the first term cancels with the one. Okay, so that's all that's left is going to be this one and this one, right? Exactly, good. Yeah. Right? Because the first one here cancels with the second one of the next one, but this doesn't have any next term. So this one is safe. And then the second term always cancels with the first one of the term before it. So this also goes away. So this one's safe, and then this one's safe because there's no term before this one to cancel. So you're just going to get negative log base 5 of 2 plus log base 5 of 50, which is the same thing as the log base 5 of 50 minus the log base 5 of 2, which is equal to the log base 5 of 50 over 2, which equals the log base 5 of 25, which is equal to 2. Nice. Love it. It's fun.
That's dope.
Yeah, safe. We didn't get canceled.
Well done.
Cool.
Well done.
Odin Roots question. Thanks, Odin. That was a fun one. That felt so much nicer than those fucking Laplace transforms. I was getting dog walked, dude, by that question. What was going on? Beautiful. Dun, 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 dun. All right, Clickbait's got a question coming up. It's getting harder and harder not to get canceled nowadays. I think it's getting easier. I will say the one positive thing about Donald Trump is that he's like kind of normalized anyone else for just being fucking batshit insane. Like, if that man can get away with saying half the shit he says, like, you're okay. You're right. I mean, back in like 2016, they were canceling people left and right for like anything. Nowadays, like, canceling a scene is like not cool, which I kind of agree with. I mean, it's kind of mean to like cancel people for like a one-word slip-up or something, like, especially if they like don't really mean it. In some ways, it's good. Yeah, dude. Yeah, out of the tragedy comes beauty every once in a while. What kind of math is this? I don't know. Clickbait, what is this, dog? Yo, hello there, Mr. Dirac function. Yeah, Diracs are cool. Yeah, so the Dirac equation isn't like the integral of infinity of like the Dirac delta just equal to like 1 or something, wherever it is or something. Right, it's 0 everywhere, but it's only 1. Is this quantum mechanics? Yeah. Looks like quantum. Oh, Dirac delta states that 0 times infinity is technically 1. Yes. I know that one. Programmers, I equals J. Mathematicians, define the Kronecker delta function. Yeah, dude. I equals J, and they're like, no, dog, it's this whole big fucking thing, dude. Yeah. Rotational motion of rigid ball. Oh, so this is classical mechanics, I think. The definition of the initial motion, the initial tensors. Sorry, the inertial tensor has a rather ugly feature. That the diagonal and off-diagonal elements are defined by completely different equations. Show the two equations can combine in a single equation. So this is what has to happen. I have to say, like, this is what happens. Okay. It's equal to the integral, though. That's kind of interesting. Rho dV equals mass. I agree with that. Yeah. Integral of rho dV is most definitely equal to mass. What is this little thing here? Is that supposed to be rho? That's supposed to be the density? Yes. Okay, cool. Okay, so I'm supposed to, I guess, I mean, these are the diagonal elements, right? So, right, this is x, this is, so, oh, I think I see where this is. Sorry, okay, so wait, so, ixx, and sorry, sum over what? Fuck, what? Sorry, this is my squared plus z squared, and then is iyy equal to mx squared plus z squared, and then izz is equal to m and then this is y squared plus, or x squared plus y squared, right? Yeah. Which, okay, this is equal to m. And then I would say this is like, so if r squared is equal to x squared plus y squared plus z squared, then this is m r squared minus x squared. This is equal to m r squared minus y squared. This is equal to m r squared minus z squared, yeah? Which I'm kind of seeing from this, right? I see the... Because we want rho r squared Kronecker delta ij minus ri rj. Yeah. So, yeah, so when I equals j, this is 1, and that gets me my r squared, and then this is like rx, and so that's minus x squared. Yes, exactly. Okay, I agree with that. Okay, that proves the diagonals to me. Diagonals are cool. How's the other one work, though? We'll see if that works. So, IXY... So, this would be m times... Okay, so I just need the diagonals. Oh, wait a minute. Negative. Oh, negative. Okay. Mm-hmm. Yes. Okay. Uh-huh. So this is m negative xy, which I guess also fits this form, right? Because Kronecker delta xy is equal to 0, and then you have minus rx ry. Okay. Which is then this. No. This is classical mechanics. Okay. So then I think I agree with this, yeah. And then this is like 0 to x, 0 to y, 0 to z. dx, dy, dz, right? I think. And then, oh, and then this is, yes. This, it's technically sum of the masses, right? Mm-hmm. Okay. Yes, so this is sum of the masses. And then it's, yes, r squared delta ij minus ri rj. And then this just becomes integral rho dv. Okay. Okay, cool. I think that's it, clickbait, right? Is that all you have to do? You just have to show that, like, the off-diagonal elements also, I mean, it kind of just, like, fits, right? Alistair, why do you insist on using my name? Looks good to me, doctor. Okay, cool. I think it's cool. Okay. That wasn't terrible. I mean, it looked complicated. That wasn't that bad.
Well done.
Alright, mark it done. Nice, good job, clickbait. The government name. Where do you submit the questions? So www.actualofficehours.com. Website right there. You can drag and drop a screenshot in, and then we'll get to it. Let's see, James is next. Am I Italian? My mother's Sicilian. Ooh, this is kind of fun. This is a stats question. It's easier to solve in the... I get it for 1 second. Use the data below to ensure if it's true that the older you are, the more money you earn. I mean, I wish that was true. Ensure both axes include a breaker to show that they don't start at 0. Scales your earnings in equal increments and good titles and units. This is kind of cool. Ugh. All right. So it looks like you don't make much. You don't make more money as you get that much older. Okay. Good thing here is to like kind of see what we have in terms of like our domain and our range. Just that'll help you like set this up. So it looks like the lowest value needs to be 22,000. The highest value needs to be around 43,000. Okay? So that means you have like 21,000 is your range in Y, right? You're going up from 22,000. I just got time warp. Yeah, switch to Twitch. Oh, is there a delay on is there a big delay on YouTube? Should be okay. Let me see. Are we Let me see what our signals look like on Twitch. It says we're okay. Oh, I rewound. Okay. Oh, you hit rewind. Yeah. That is a cool thing about YouTube, is that if something doesn't make sense, you can actually like live rewind it. It's pretty cool. Okay, so this is like 21,000. How many markers do I have? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have like 16 markers. So 1,000 per marker would actually work here, right? Because that would get me up to no, it wouldn't actually. Oops. That'd only get me up to 38. Oh, okay. So we got to use 2,000 per marker. I thought I was back at the Laplace question. I thought this was a nightmare. Yeah. Hey, Alistair, I welcome the easy questions every once in a while because, dude, fuck that Laplace question, dude.
Surprise, motherfucker.
That was so bad. Okay. And then we're going to want it to start. So this is cool. This is called a line break because this is 0, for instance. But you have to show that this, like, jumps. And so how you do that in graphing land, I'll do this in red, is you do something like this. You do, like, a little, like, heartbeat. Like that. There you go. That's how you do that. And so let's have this start at 20,000. And then I'm going to have it go by 2,000 each one. So this would be 22, 24, 26, 28, 30. So this would be 30,000. And then 1, 2, 3, 4, 5. This would be 40,000. And then 1, 2, 3, 4, 5. Cool. 1, 2, 3, 4, 5. Yeah, this would be 50,000. And then technically you would want to say like earnings in dollars here. Yeah, no, exactly. Exactly right. Also, like, I mean, this stream is for everybody. It mainly was intended for high school students. So I'm happy doing high school level questions because I don't want to like scare off all the high school kids with the Laplace transforms constantly. So whom do I miss you? Yes, I always miss you, dude. And then age goes from 25 to 75. So that's and I assume we have 15 markers. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So with 16 markers, I think like 4 years per marker works, right? Because that'll get me 64, which would get me 89. If I did it 3, it wouldn't work, right? Because 48 plus 25 is 73. Oh, damn, it's just barely there. Okay, so we can do it. Yeah, we'll use 4 per mark. So this is on the y-axis. It's on the x-axis. Rage baits. What's the rage baits on this? What are you rage baiting me on, dog? And then let's have it start at 25. I think that's cool. Let's start at 25. So 25. What's up, Dud? What's up, bro? So 29, 36, 40. No, sorry, I fucked that up. Sorry, by 4. 29, 33, 37, 41, 45. That's what I want. Right, because it's 20 years every 5. 1, 2, 3, 4. Right, 5. 1, 2, 3, 4, 5. So this is 65. 1, 2, 3, 4, 5. This is 85. Nice. Love. Because every 5 is 20 years. Thank you, Kenny, dude.
Good job.
Thank you for the 2 diamonds, man. It's so nice of you. Much love, dude. Okay. And like usually for like, you know, good titles and units. So you could say like this would be like, for instance, like age in years. And then this is earnings in dollars. And then for the title, you could say, usually you can just say like Y versus X. You can say like earnings versus age. Oh, thank you, dude. Yep. Cool. Okay, now plot this. Okay, so here, we'll just do it real quick. Because what was our units? Right, it's 2K per unit there, and it's 4 there. Okay. So 22,000, that's going to be one above. It's going to be like right here. 30 is like, well, this is 29. So that's 2, so that's 1. 26, 22, 24, 26. 26.5 is like right here. I'm going to plot just some of these points. Just to save us a little bit of time. Like 45 is at 36,000. Okay. Where's 36? So there's 30, 32, 34, 36. So this is another one. 60. Yeah, where's the peak? The peak is at 65. Okay, cool. 65 is 43,000. The nice thing about this is I have a line. I can just draw a line. And then 43,000 is... So this is 2,000, so then we're halfway in between this. That's right here. Okay, cool. So this is this. Nice. And then... Let's get another big one up there. Yeah, let's get like 75, right? So 65, 69.
Nice.
73. And then up by 2, 75. So it's right here. Yeah, dude, this is not a line investment, though. It's not linear, dude, right? 37.5. That's 38. This is like 37. It's like 37.5 is like right here. Okay, so it's like this. Cool. There we go. All right, so here's like some points. It says, what's the general trend shown by your best fit line? So yeah, if you do a linear trend on this, it would kind of look like this, right? I agree. It would kind of look something like this. The soundboard, right? We do love the soundboard. So what's the general trend? I would say it's a positive trend. Is that what we say? Do we say positive? Does it generally support the hypothesis? Yes. About how much more does a person earn per year in general? Ooh. So, I mean, I would take this point and this point and like subtract them, right? So I would do 43,000 because that's the Y point for the highest one, minus 22,000, and then divide that by the age at 43,000, which was 65, minus the age for the 22,000, which was 25. So that equals like 21,000 over 40, and cancel some zeros. 2,100 over 4? Is that 525? I think that is actually. Right? Yeah, 4 times 500 is 2,000. Okay, cool. So about $525. You can say extra dollars per year. Is there an area of the graph that doesn't seem to follow this trend? Yes. I could say like after 65. Can you explain why? Retirement. People stop making money when they retire. Okay, nice. And then you could use it doing, yeah, you could do it with a spreadsheet. I saw a gambling stream and a person peddling an obvious crypto scam after you accidentally scrolled. Yeah, don't go down, dude. Don't do it. Stay here. It's safe. Ageism, yeah, that's why, dude. Cool. Okay. Cool question, James. I hope that helped you out. I liked it. It was a nice, so soothing. That's so soothing.
Well done! Well done!
Okay, Riley, your question's next. Is this one gonna hurt me, Riley? Gonna hurt me? We're getting hurt with like more like Laplace transform stuff. Please don't rank on me for this question. I skipped this week's of lectures. Okay. Let's see what we got. Let's see what we got. Riley's question, 17.4. We're at 17.4. There it is. Find the Fourier series expansion of the backward sawtooth waveform. Obtain the amplitude and spectra. Oh God. Oh man. I mean, I see a period on it, which is nice, right? And I see an amplitude, which is cool. Right? Okay. This is where like I just want Fourier transform for sawtooth. What is it? just there we go. Love it. There we go. Yeah. Ooh, so this would be a positive sawtooth wave, but then we have a negative one. Yeah. Sum from 1 to infinity sine of nx. Yeah. That's what we're seeing here. So, I believe theirs is a little bit different because theirs is inverted, right? It's a backwards it's a backwards. It's okay. You're good, dude. Okay. Well, okay, wait. So A0 is equal to 1 over the period, right? 0 to the period. And then that's f of t dt. And so here, period is equal to 2. F of t is equal to negative a over t, right? Because that's the line. Negative a over t times t, right? Oh, 1 minus t. Yeah, actually, sorry. I'm wrong. Sorry. It's 1 minus a over t times t. Well, sorry. It's a times 1 minus T over T? I think that's what it is, right? Because when T equals 0, it's at the amplitude. And when T equals the period, it's equal to 0. Yes. Okay. So, yeah, amplitude is equal to 10. So this is equal to... Yeah, no. I think it's this. I see. Like, does the shift matter, right? Yeah. And then, yeah, so minus 5t then? Is that what it is? What's up, Bugsy? What's up, Bugsy? Yeah, Riley says that's what I was using. Okay. So, this should be 1 over 2. Integral of 10 minus 5t from 0 to 2. dt. So, what's that? 20 minus 5 halves times 4? Alright, integral of 5t is 5t squared over 2. Oh, so it's just equal to 10. Wait, and there's another 1/2 out front, sorry. So it's equal to 5. Oh, interesting. That's still a over 2. That's pretty cool. Yeah, that's the DC offset. You're right, that's the average. The other coefficients are worse. Bugsy, you need some help? Cool. Submit a question to our website, dude. I'll help you out with it. That's where it is. All right, one second. Make sure. I might have someone like trying to visit me somewhere. All right, how do we get the coefficients? So if it's odd, I think a of n is equal to 0 then? Is b of n still equal to this sine n omega t? Yeah, so I think a of n equals 0 because f of t is odd. Odd about like whatever the midpoint of it is, right? I think the shift we'll take care of. That'll be the phase shift. We're gonna assume that this is a sawtooth that's centered around equal to 0, I think, Riley. And then we're going to introduce a phase shift. Okay, so then b sub n is equal to 2 over 2. Well, that's nice. That's just 1. Okay. 0 to 2. 10 minus 5t. And then that's sine n omega. But omega is equal to 2 pi f, which is equal to 2 pi over t. Oh, that just equals to pi, because t is 2. Yes. Exactly. Cool. Okay. So that's n pi t dt. Okay. So, I mean, this one's not integration by parts, right? This is just standard. So that's 10 integral from 0 to 2 sine n pi t dt. This one is kind of a pain. Minus 5 integral from 0 to 2 t sine n pi t dt. But wait a minute. This integral, this is basically integrating, right? From sine of 0 to sine of 2 pi. Isn't this just going to be 0? This is 0. Yeah. Because the integral of sine over 0 to 2 pi, that equals 0. Because we're going from 0 to sine 2 pi n, right? Nice. So this one's actually just 0. That's cool. This one I do have to do integration by parts. That's okay. So here this is u. So u is equal to t. So du equals dt. And then dv is equal to sine n pi t dt. So v is equal to 1 over n pi negative 1 over n pi cosine n pi t. Cool. So uv, so that's negative t over n pi cosine n pi t from 0 to 2. Which I think this is also just going to end up being 0. Right? Because again, we're doing cosine from 0 to 2 pi. So this one goes away. And then minus, so that's plus 1 over n pi integral of cosine n pi t dt. Okay. Integral of cosine is sine. Dun. Oh, wait a minute. Wait, sorry. There's a T on this. Oh, wait. Wait a minute. Right. One sec. Sorry. This integral is 0. Not this one. Yeah. This one goes away. This one's okay. Sorry, this is the result of it. Yeah, sorry, my bad. This is negative 2 over n pi. Yeah, sorry. I was getting carried away. I thought I still had an integral on this. I don't. And then this is cosine of 2 pi t. Right. The 0 1 goes away, yeah? Okay. And cosine of 2 pi t is just 1. So this is just negative 2 over n pi. Correct. This one goes away. This is equal to 0. Okay. Okay, oh, so you just get negative 2 over n pi. Okay. So b of n is equal to negative 2 over n pi. It's actually pretty close to what we already have. Right? That's kind of what they had here. Pretty sure there's an a over n squared pi squared somewhere. Wait, and all this was times 5. Oh, so it's positive 10. Okay, actually, ooh, I messed this up. Okay, this is b of n. So I think we're done then, no? Let me see what was in this video real quick. Love this guy, Michael Van Beezen. Okay. What does he get then? Okay, so we got the BN, but then what does he do? How does he write this? Okay, so it's equal to A0 plus B0 sine n omega t, and then that's a series. Okay. So the Fourier says so. Okay, so and then that's going to be Bn sine n pi t. It should be, but omega is just pi. Yeah. So that's equal to, what was our A0? A0 was 5. Plus the sum from n equals 1 to infinity. And then I think it's just 10 over n pi sine of n pi t. Right? Can you do the spectra as well? Okay, I can try. Amplitude and phase spectra. Well, this is the amplitude, right? So I think this is the amplitude. What is the phase spectra though? Yep, I'll give you 1 sec. Is there a way to increase the timer? No, the timer is what the timer is. Sorry, my TikTok chat stopped. Why does it fuck up? I need to. My bad, TikTok. Sorry. Sometimes the chat stops. Thank you, Trollcast, dude. We are 20 minutes. We are 20 minutes left. Nightbot, nobody was talking to you. Why is my TikTok chat not working? Please work. So let me fix this real quick. I feel like the phasing is just 0. Check on this. I think the phase spectrum is just 0. I'm confused. Because usually it's like it's n pi t plus phi. But in this case, like phi is equal to 0. And I don't see anything negative here. Although, wait a minute. This is kind of weird, though. If I need it to be decreasing. Bro, we're learning... No, this is Fourier series. This is a Fourier series question we're actually doing here. Yeah. Yeah, MMD is asking... Yeah, what's the... Okay, thank you, Salma. You're about to solve the Laplace one? Thank you. Okay, I'm gonna say this is as good as we got it, but I will also post it, and hopefully someone else can check it on me. But cool. Fun question, man.
Good job.
Riley. There we go. Fourier series.
Good job.
Zach, if you want to check this for me, I think I got it right. I'm not sure. It's kind of like signals. Did I pass my final? I don't know if I passed my final, dude. It was brutal, dude. It was very messy. Shout out to Zach, by the way. Another awesome math streamer. Do you guys use this stuff in physics? We do, but we kind of just like use functions that we know work for it, like Python scripts. So I had this actually when I was on a podcast with Zach. We were talking about Fourier series and how there is like this nice formal math definition for how to come up with them, but in experimental plasma physics, at least, we just kind of learn how to use it as a tool. We don't really learn like what's the science behind it. Riley says, thanks for helping with my niche ass question, man. Oh, that's cool. I mean, it's not super niche. I mean the class is very niche, yes, but the idea of like Fourier series is not very niche, because That gets done in a lot of different math classes. And yeah, Zach's kind of like the expert on this type of stuff. So I'll post this to our Discord, and we'll see if Zach maybe wants to like look at it and see if I did it right. I may have done something wrong, honestly. Are you working at university? So, funny enough, so I have taught at UCLA for sure. I taught in the spring. I did my PhD at UCLA. That's when I say like experimental like plasma physics stuff. Like that was what I did for my PhD. I did teach at UCLA in the spring of this year, and I taught in the summer. I'm not teaching right now because they're going through like some financial issues, and didn't have money to like pay me to teach a class. And I was like, whatever, like I'll just keep doing what I'm doing here. But then funny enough, I just got this email, by the way. This email's so fucking hilarious, dude. Look at this email I got today. They said, "Dear Giovanni, I'm happy to let you know that you're the recipient of a Departmental Outstanding Teaching Award." So apparently I'm getting an award at UCLA for their Christmas party. They're like, "You won the Department Outstanding Teaching Award," but I'm not fucking teaching this quarter because you don't have any money. But for the times I was teaching, apparently I got an award. So it's funny. Yeah, I'm gonna show up to this Christmas thing, I guess, next week and accept my award for being an outstanding teacher in physics, but I'm not currently teaching physics there. Yeah, that happened to me the year I graduated when I wasn't teaching either. Yeah, I'm just like, whatever, that'll be a fun little plaque. It's just funny how like the university, dude, academia and the university, higher education is in a very weird place right now. So we're doing our best to help out here, you know, with our live streams. Fake it till you make it. I don't know if I faked it that time. Okay. Jess asked this question. Is this a real question we can solve? I forget if this is actually real. Am I happy with being a professor? There's a lot of issues. I enjoy teaching. Don't get me wrong. Love to teach. I'm very happy with teaching. And I think I give a shit more than most do. I'm just... The administration and all the politics is pretty trash. No. There's not really much you can do about it. So, I have a lot of frustrations with that. The teaching part's great. I love teaching. I'll teach all... I mean, that's what we're doing. That's what we've been doing here for the last 3 hours. Yeah. Any plans on teaching more as a university lecturer? If they offered it to me again, I might take it. It is honestly a lot of work, and you don't get paid very much. So, I enjoyed doing it. It was almost kind of like charity, honestly, when I was doing it. For the amount that they're paying you, it's pretty bad. But for me, it was great for... I wanted to have like some formal teaching experience on my resume. So I've been teaching for 15 years like this. But whenever people like were like, "Oh, well, do you have a teaching certificate?" I'm like, no. Don't really need one. But now, if people really ask like, "Do you have formal teaching?" I'll be like, "Yes, look, I taught at UCLA for 2 quarters. They gave me a shiny plaque. I'm like, what else do you want?" Okay. Come to UNF? What? Is the pay not 100K as you teach longer? For lecturers, I don't think so. I think it's kind of capped at like 80, which is not enough to live in LA. You can't really live on 80K. Increasingly more and more difficult to do that. If they offered me a teaching professor position, like that's a different like higher level one, that's like 120K, I would take that. I would do that. I teach for 120K. Okay, let me see. Who did... Bum, bum, ba-dum. This is an issue. Right? There's an issue at x equals 1 here. Right? This becomes a problem. So do you have to take the limit as x approaches 1? And wait, and it also breaks at 0. Wait, there's so many issues here. Wait, what? Yeah, and then that also... Well, that's okay here. Arc cotangent, dude, what? I'm throwing this one at ChatGPT. Come here, chat. Come here, chat. Got a nice question for you to chew on today. Bro, who wrote this question? I don't know. Someone being funny. Jess did, apparently. Let's see. Set the classical tangent half angle substitution. Can we see the question, Gio? Yes, you can always see the question if you go to the website, actualofficehours.com, click on live queue. Here's all the questions that are being asked, and just click on the username. If you click on the username here, the question pops up. Sorry, but let me see what's happening here. Set the classical half angle substitution. X is equal to 1 minus t squared over 1 plus t squared. So 1 plus x over 1 minus x is 1 over t squared. Sure. Oh, and then dt is equal to this. Also, x is equal to that. So yeah. Oh, this is cool. Therefore, everything here, this 1 over x is square root of 1 plus x over 1 minus x, converts into this. Flipping the limits, and as when x equals when x is from -1 to 1, we have t goes from infinity to 0. Okay. I see, but wait, we haven't converted this to t yet. But then they use the same substitution here. Use a quicker invariant approach. Fun. Okay, blah, 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 blah. Equals that. Okay. So the integral is that. And then you got to do partial fractions. And then... Cool. I believe it. Yeah, okay. Wait, the last identity is the essential special function that produces the golden ratio. The ln of 1 minus t squared over 1 plus t squared from 0 to infinity is negative pi times the arc cotangent of the golden ratio. Wow, that's cool. Nice. Cool. Okay. Apparently that's the solution. I wasn't going to figure that all out on my own, especially not in the next 6 minutes. But that was cool. I'll post it though. Let's do it by hand. Let's not. Yeah. Thank you, dude. Thank you, Troll Cats. Yeah, so sorry. Yeah, the solution to this one is kind of a mess. This whole thing is all of this. There's some cool tricks in it, for sure. You know, I'll share the link for this if people want to read. It's fun to read through these things. But in doing so, I'm kind of like, yeah, I'm going to pass.
Surprise, motherfucker.
Because, like, it's always going to hurt me. It hurt me really hard. That link will show up eventually. Okay. More sequences? Millie, I just did one your question those. Let me do someone who hasn't asked a question yet, sorry. What about Bugsy? Bugsy, you were waiting for a bit. I know you're in my chat. Let me do Bugsy's real quick. This looks beautiful. Bugsy, I can help you out here. Just throwing out there, I fuck with the mullet. Your LinkedIn. Thanks, dude. I don't have that mullet anymore. I need to get it. I need to get new pictures on LinkedIn. Let me help out Bugsy. Bugsy, you still in my chat, dude? Bugsy had this question. This is a fun one. 4 plus 26n. I love like a nice little soothing question here, dude. This is very nice, Bugsy. These are similar terms. So 26n's minus 13n's is 13n's. And then whenever you're trying to solve for n here, Bugsy, just look at what's happening like the furthest away from it and do the opposite. So the 13 is pretty close to it, and that's multiplying. So we're not going to deal with that yet. This is pretty far away, the plus 4, so I'm going to minus 4 from both sides. So then I get that 13n is equal to negative 52. Last step, divide by 13. And you get n is equal to negative 4. Nice. Cool. Good question, Bugsy.
That's dope. Well done. Well done.
Dun, 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 dun. I don't think I've ever been happier to see a question. Yeah, we've had some brutal ones today. Wait, is it still trying to find a link to this one? Come on, dude. Hurry up, dude. I know. There, yeah, can I have it? Thank you. Let me copy that link for people. Ooh, yeah. Is that the one on Netflix, by the way, Zach? The Legend of the 5 Mile Cave. Is that the one about the people in Thailand that were stuck? Or am I thinking about a different cave? You know the one where like Elon Musk said he was gonna like send people to like fix it? Oh yeah, wait, much different. Okay. Yeah. Okay. Oh, it's a Western. Okay, that's cool. Okay, nice. This one was Bugsy's. Bugsy, I'm gonna post a solution in our Discord so you can see it. Let me see. I got a minute left. Is there anything quick I could do in a minute? Hell yeah, I could probably do this in a minute, honestly. Or Ali v2. Define a function. I'm gonna leave this one for my other math people to do. Poisoned. This is also a differential equation. This is like the wave equation, I think. Jesus Christ, what is this? Yeah, I don't know about this one. And a milli. Yeah, here. Alright, the last question for the day, because I am going to run out of time pretty soon here. I'm going to help out Charles. What time is the Riemann surfaces stream? Good question, by the way. If you want to figure out whenever the other people are streaming, click here on streaming schedule. And here's the calendar of everyone when they stream. So Penn Center and Academy of Useless and Collar are going to be doing Riemann surfaces starting at 2 p.m. Pacific. So 4 hours prior to now. And it's on Wednesday. Yeah, everything's on the calendar there. Comida en la casa. Yeah. Food in the house. All right, I got you, Charles. I'm sure they'll record it at some point. Okay, cool. This one's actually pretty fun. So because this is, let's assume this is a right angle. If this one's 45 degrees, this also has to be 45 degrees. Because you need all of the things to add up to 180. Right? So I mean you could do it manually this way if you wanted to, right? So 45 plus 90 plus A has to be equal to 180. And so that's 135 plus A equals 180. So A equals 45 degrees. And then the fun thing is, if this is 45 degrees and this is 45 degrees, then their sides are the same. So in a right triangle, the length of your side is proportion to how big your angle is. So if you have the same angles, then the sides opposite are also the same. So this means x is also equal to 8. And then from this is technically the square root of 16, but you can figure it out using Pythagorean theorem. So 8 squared plus 8 squared is equal to y squared. So that's 128 is equal to y squared. So y is equal to the square root of 128. What is that? 8 squared root of 2? Because this is 64 and 2, and then this is 8 and 8. So that equals 8 squared root of 2. Oh, you don't like the orangey pen? Okay. Here, I'll go back to blue. Okay, solve for r and theta. Okay. So r squared equals 7 squared plus 3 squared. So that equals 49 plus 9.
Which equals to 58. And then we got baby boys coming in here, right? Yeah. So r is equal to the square root of 58. Theta. So you could say that the tangent... I got it wrong, man. I don't know what that question is. Which one? Which one did you get wrong? You need to drink water. Okay, so tangent of theta is equal to opposite over adjacent, 3 over 7. So theta is equal to the arctangent of 3 over 7.
Which, we need to calculate for this one. 8 divided by 8 equals 1. 1 plus 1 equals 2. Good, right? So let's do that. Let's do the arctangent. 3 over 7. L? No. It's acceptable. I think we're also going to just say it's equal to 23.2 degrees. Unless you write it as a series. Okay. Solve for BC and the height. Cool. So here, I know this is 60. So the sine of 24 degrees is equal to the opposite, which is BC over... Or actually, let's do tangent. Sorry, let's not do sine. Sorry. So tangent of 24 degrees is equal to the opposite, BC, over the adjacent, which is 60. So BC equals 60 tangent 24 degrees. So tangent of 24 plus 60. Or times 60, sorry. Did that wrong. So that's equal 26.7. And then total height is going to be that plus... Is that 15? Dude, what dude is 15 meters? I think that's 1.5, right? Definitely not the scale, though. So that's going to be 28.2 meters. Nice. Good question there, Charles. Nice. Cool. Fun. Nice little trig. Nice little trig work out. Charles! See, was that Charles's? That was Charles's. Okay. Looks like that's all the questions for today, so let's close out the stream. Alright, thank you everyone for coming to office hours today. Had a lot of fun running through questions with you guys. Some of these were definitely really hard, like kind of brutal, honestly. But I enjoyed them. I always like learn something. I don't know if I passed my Fourier transform final. Not my Fourier transform final, sorry, my Laplace transform final. But I definitely got to cut my teeth on it a little bit, so. The Fourier stuff, I was kind of like, yeah, pretty brutal questions tonight. They happen, it's okay. I appreciate the struggle. Struggle makes magic. But yeah, if you're just finding us right now, again, welcome. Stream is about to end. But if we didn't get to your question today, not to worry. It's going to get posted in our Discord, and we have a wonderful team of awesome actual educators who donate their time to answer some of them in their free time. So your question may get answered either during somebody else's stream or off, I say like after hours or whatnot. So don't worry. Thank you so much, Professor. Have a great night. Be my friend on LinkedIn. Yes, please friend me on LinkedIn. I need more connections. Yeah, send me as many, connect with me as much as you want on LinkedIn. Yeah. Maybe this would help. Stanford Engineering. Ooh, the Fourier Transformers applications. Oh, this is cool. So there's, oh, this is like a course for it. Oh, and they have videos. Oh, wow, you can watch all the lectures. Oh, that's super cool. Hello, came from scrolling. What's up, Burrito? All right, we're just ending right now, but I am going to go raid somebody. So let's go see who else is streaming on this beautiful Monday. Who do we got? Can you put that link on the Discord? I can. Here, I'll put it in your course. Where was, not your course, sorry, your question. Riley's question. Okay. Yeah. There you go. I put the link there. It's right there. Right there. Sweet. Okay. Let's go raid someone. Who are we gonna go raid? Who am I following? Late stream. Yeah, it's okay. Ooh, Obi's on. Springer Math Education Research Journal. Yeah, math news. And he's been online for 4 hours. Let's go bug him. Okay. Go say hi to Obi or good night to him. Have a wonderful start of your week. We will see you tomorrow. Peace.
Required adaptations, the end of OAB, therefore could have influenced the overall picture. To compare teachers' adaptation measures between the start of OAB and end OAB, it's useful to analyze the codings of Group B to the subcategories reduction, expansion, and non-content adaptations. Distribution of the subcategories in the main category reduction is displayed in Figure 6.